Alright, so today's lesson is for Thursday, October 6, 2011. We're going to begin by going over a PowerPoint on some of the kinematic equations that we haven't covered yet, and you'll basically get to see when is the best time to use those equations, and you'll get some practice on using them in word problems. We'll go over some examples and that sort of thing. From there, you guys will be doing some independent practice on your own, where you're going to go ahead and solve some equations on your own, and if you have any questions, you'll be able to ask here in class before you leave. So let's go ahead and begin with this PowerPoint. You should have a handout, and on your handout I'll be wanting you to fill in any missing areas that you see on this PowerPoint. Just make sure it's complete when we start. Again, we are talking about kinematic equations and when to use those kinematic equations for different word problems. So basically, we're going to learn how to decide on which equation to use. Alright, so here at the beginning, we're going to start with a really basic equation that we've used before, kind of get your feet wet. So A is acceleration, and the units for it are meters per second, and in this case it's equal to the final velocity, again meters per second for the units, minus initial velocity, meters per second, divided by the time. So you want to go ahead and write these into your paper. Now, we've already seen examples of this problem in the past. We did some problems yesterday using this equation, and the real key here is that when you look at a word problem, you're going to find that this equation is only used on word problems where there is no displacement in the word problem. So you won't see anything with meters in the given information that you're pulling from the word problem itself. And that's going to be a really important thing. You want to make sure that you understand that the displacement is not used in the word problem when you're choosing this equation for that word problem. Again, we're going to see an example of that in just a minute where we have to decide on that. Okay, you're also going to find that the word problem gives you values for 3 of the variables listed, and it's asking you to find a 4th. So does that mean that they have to be asking for acceleration? No, they don't. They can be asking for final velocity, they could be asking for initial velocity, or they could be asking for time. Now the key here is that it contains all three of these variables in the given, and it has one of them in an unknown section for you. Okay? So let's go ahead and look at an example where we're going to use this. Let's go ahead and pick a color that will look good here. So the first step, like we've discussed, is to identify the important information. So we've got that 10 seconds, you've got a 4 meters per second squared and a 60 meters per second over here. And in our G step, we're going to go ahead and write out the given information. So we've got a time, and that's 10 seconds. And then we've got an acceleration over here, 4 meters per second squared. And we're going to be going to a speed of 60 meters per second. So that's going to be our final velocity. Okay, the unknown step here is going to be where we write down what we were looking for. So if we look at this problem, they're talking about this beetle accelerating to the speed. They want to know how fast he was going before he accelerated. So our unknown here is going to be the initial velocity. Okay, the equation, we're going to use the equation that I just showed you. So it'll be acceleration equals Vf minus Vi divided by the time. Okay, so we're going to go ahead and plug in this information into the equation for the substitution step. And for that, we'll end up with 4 meters per second squared for acceleration is equal to 60 meters per second for the final velocity minus the initial velocity divided by the time, which in this case is 10 seconds. Alright, to do this, you're just going to have to use some algebra to solve for Vi. And pretty simple. All that we're going to have to do is begin by multiplying both sides by 10. So when we multiply both sides by 10, we're going to go ahead and show that we're doing that. So 4 times 10 is 40. We end up with 40 is equal to 60 minus Vi. And then to get rid of this 60, it's being added on this side, so we're going to subtract 60 to both sides. I'm going to continue the work up here. So when we subtract 40 minus 60, you get negative 20 is equal to, and then on this side, 60 minus 60 cancels out, so you end up with 0 minus vi. Now to get rid of this negative here, because it's being multiplied, a negative 1 times vi, you just divide by a negative 1. And you end up with negative 20 divided by negative 1 is a positive 20 equals vi. So that would be our solution. The initial velocity for this beetle would have been 20 meters per second. Actually, I should go ahead and write that in, right, because it doesn't look good just like that. So the initial velocity equals 20 meters per second. All right, so for this problem, again, in this case, they didn't solve for acceleration. They were asking you to solve for the initial velocity. The way that I chose this equation was because there was no displacement at the top. They weren't asking for you, they didn't give you displacement, and they weren't asking you to find displacement. So it wasn't even used in this problem. The four variables that were used were time, acceleration, final velocity, and initial velocity. So that's how you decide on using that equation. Okay, so this other equation is for calculating word problems where you're not given an acceleration, and it's going to be displacement equals 1/2 times the initial velocity plus the final velocity times the time. You'll notice that we have the units for displacement as meters, initial velocity is meters per second, final velocity is meters per second, and time is in seconds. So the first thing you have to do to decide, when you're using this equation is you have to go ahead and look at the word problem and see what givens you have and what they're asking for, your unknown. And if the word problem does not have any given for acceleration and it's not asking you to find acceleration, this is probably going to be the equation for you if it gives you 3 out of the 4 variables. So if in your given you have 3 out of 4 variables, you can use this equation to find the 4th unknown variable. Sorry, I'm getting distracted. So for this practice problem over here, again, we'll start by identifying the important information in the problem. So we've got this first thing. They tell you that Mr. Urby's toy car is at rest when a poltergeist suddenly swats it to a velocity of 20 meters per second. So there's another piece of important information. And they say that you're traveling 80 meters across the lawn. So there's another piece. And they want to know how much time did it take you to do that. So if we go ahead and look at this word problem, we're going to start by identifying the givens. And in this case, the fact that it starts at rest tells you that that's your initial velocity, 0 meters per second. They tell you that the poltergeist swats it to a velocity of 20 meters per second, so that's going to be your final velocity, 20 meters per second. And they tell you that you do that for 80 meters, so that's going to be your displacement. And they want to know how much time it takes. So our unknown here is going to be time. The equation is going to be the equation we just discussed, and again, the way that I come to that decision is the fact that there's no acceleration either in the given information or the unknown. Okay, we have 3 of the variables that we need for this equation, which is displacement equals 1/2 times vi plus vf times t. Okay, so we have all 3 of these variables and we're trying to find time, so we'll just go ahead and substitute the information in, and it's going to be 80 meters equals 1/2 times 0 plus 20 times the time. Now, here it's just going to be simplification of the problem before you actually plug it into your calculator, I guess. So we're going to do 0 plus 20, which is 20. So we end up with 1/2 times 20t equals 80 meters. And then 20 times 1/2 is 10. So you end up with 10t equals 80 meters. You divide both sides by 10. The 10 cancels over here. And our solution is going to end up being 80 divided by 10, which is 8. So for the solution over here, we'll go ahead and write in that the time was 8 seconds. Alright, so again, this is a problem where you'd be given the VI, the initial velocity, the final velocity, the displacement, you're trying to find time. Again, it didn't ask you to solve for change in x or displacement. It asked you to solve for time, but I knew that this was the right equation to solve for time because it actually went ahead and showed me 3 of the variables, and it asked me to find a 4th one, and they're all present in this equation, which is very important. Okay, so let's go ahead and look at the next example. Okay, so for this equation, we have displacement equals your initial velocity times time plus 1/2 times your acceleration times time squared. Now for this equation, you're going to notice, again, write these in. Displacement is in meters, initial velocity in meters per second, acceleration is in meters per second squared, and time is in seconds. For this equation, you're going to see that the final velocity is not going to be used in word problems. So if you find that when you've gone through your word problem and you've written out your givens and your unknown and you see that final velocity is not used, it's very likely that this is the equation that you'll be using to solve that problem. So again, it's very important that after you do that given and unknown step, you refer back to this to decide, which equation you should use based on that. This will be the equation we use whenever final velocity isn't given to us. Okay, so in this example problem, if we go ahead and look at this, a tornado moves across the yard at 12 meters, so I'm going to want to highlight that, in 4 seconds. If it has an initial velocity of 5 meters per second, what is the acceleration of the tornado? So when we look at this problem, the givens here, we've got 12 meters is the distance, or displacement, sorry. So our change in x is equal to 12 meters. And then you've got the 4 seconds, which is going to be your time. And we know that it has an initial velocity of 5 meters per second. So we'll go ahead and put initial velocity here of 5 meters per second. The unknown here is going to be the acceleration. They want to know what the acceleration of the tornado is. All right. So the equation here that we're going to decide, again, I look at the givens and I'm going to see that we have displacement, time, initial velocity, and acceleration, which are the 4 variables that we need for the equation I just showed you. And we also know that final velocity isn't present in the givens or the unknown. So the equation that best suits this problem is going to be change in x equals vi, initial velocity, times time, plus 1/2 at squared. Alright, so actually I need to go ahead and fix that because we're not squaring the whole thing, we're only squaring that one part for time. So we'll go ahead and put time in parentheses, we're going to square that in that way. Alright, so the substitution step here, we're just going to go ahead and get this stuff and plug it into the equation. So it's going to be 12 meters equals 5 meters per second times the time, which is 4 seconds. And then we're going to add this segment here, which will be 1/2 acceleration, which is what we're looking for, times the time, which is 4 seconds squared. Now again, the time is the only thing that's squared here. Okay, so when we simplify this and actually do some of the multiplication and get some stuff out of the way, we'll do 5 times 4, which is 20. And then we're going to add, I'm going to put the 12 over here. So 12 equals 20, 5 times 4, plus 4 squared is 16. 16 times 1/2 is 8. So time plus 8 times a. So again, we do the 4 squared, which is 16, multiply it by the 1/2 that's in front, and you get 8. We multiply that by the unknown here, acceleration. So we're adding 20 on this side, so we'll subtract 20 to both sides. So over here we get 12 minus 20, which is going to be a -8, is equal to 8 times the acceleration. We divide both sides by 8, and you get over here as a solution, acceleration equals -8 divided by 8 is a -1 per second squared. Okay, so this tornado was accelerating at -1 meters per second squared, which means it was slowing down. All right. So this next equation we're going to be looking at basically is going to be displacement equals final velocity times time minus 1/2 acceleration times time squared. Again, pay attention to the units and write them in. We're going to be using this equation whenever there is no initial velocity in the word problem. So this will be an example where, again, there's no initial velocity either in the givens or the unknown portion of the equation. So we should have the other four variables present either in the given section or the unknown. Okay, so we have to have these four variables for sure to be able to use this. It should just be missing the final velocity. Okay, so that'll become important. Sorry, I lost control of my mouse there for a second. Alright, so for this first word problem, it says the witch is traveling on her broomstick for 50 meters horizontally for 10 seconds. We'll go ahead and identify those. 50 meters, 10 seconds. If you know the witch was accelerating at 2 meters per second squared, you need to calculate the final velocity. Okay, so for the givens here, we're going to have the displacement, which is 50 meters. You're going to have the time, which is 10 seconds. You're going to have the acceleration, which is 2 meters per second squared, and they're going to want you to calculate the final velocity. So the unknown here is the final velocity. The equation will be the one that we just talked about. So you'll be using the equation that says the change in displacement, or the displacement is equal to final velocity times time minus 1/2 times your acceleration times time squared. Alright, so we're going to go ahead and plug all this information in to our substitution step. So it'll be 50 meters equals your final velocity, which we don't know yet, times your time of 10 seconds minus 1/2 times 2 meters per second squared times the time of 10 seconds squared. Alright, so 10 squared is 100. 100 times 2 would be 200. 200 times 1/2 is 100. So we've got 100 over here, and then we're going to go ahead and write the 10 VF over here is equal to the 50. And we're going to add 100 to both sides to get rid of it over here. So we're going to end up with 150 is equal to 10 times the final velocity. To get rid of the 10, you'll divide both sides by 10. And you'll end up with a solution where your final velocity is equal to 150 divided by 10, which is 15 meters per second. Okay, so this witch was traveling a final velocity of 15 meters per second. So again, this would be an example where you're given the 3 out of the 4 variables for this equation, and you're looking for the fourth unknown, where they don't actually give you an initial velocity. Okay, so no initial velocity. Alright, the final equation we're going to go over is the one we're going to use whenever time is not present. So the final velocity here, initial velocity, acceleration, and displacement should be there, but there won't be any time actually in the word problem. Okay, so time will not be used. So if we go ahead and look at the word problem here for this one, we've got a zombie is chasing you at 0.5 meters per second. When it catches a whiff of your brains, it accelerates at 3 meters per second squared to a new speed of 8 meters per second. What was the zombie's displacement during that time? So the given here is going to be the fact that it was starting, its initial velocity was 0.5 meters per second squared. Meters per second, not squared. The final velocity here is going to be the 8 meters per second. The acceleration is going to be 3 meters per second squared. And we're going to go to a new speed. We're going to try to find the displacement. So the unknown here is change in x. Okay, so the equation that we're going to use is going to be the VF squared equals VI squared plus 2A times the displacement. We'll go ahead and substitute everything in, and we'll end up with 8 meters per second squared equals 0.5 meters per second squared plus 2 times the 3 meters per second squared times the displacement change in x. So the solution here is going to be to simplify all this stuff first, and we're going to go ahead and start with the 8, so it would be 8 squared, which is 64, is equal to 0.5 squared, which is 0.25, and we're going to add the 2 times the 3, which is 6, so it's going to be 6 times the change in x. Alright, so from here we're going to subtract 0.25 on both sides to get rid of it on this side. So 64 minus 0.25 is going to give you 63.75, and that's going to be equal to 6 times the displacement. And then we're just going to divide that by 6, and you're going to get a displacement as your solution of 10.6 meters. Alright, so your displacement here for the zombie during that time that he accelerated would be 10.6 meters. Alright, so that concludes all the practice problems. From here, you'll just go ahead and go to your weekly agenda. And in that weekly agenda, you'll be doing the kinematic and linear equations practice. So that's all for today's lesson.